To get started, we're going to create the state machine and the state in parallel. The state machine is going to use the state, and the state is going to reference the state machine. So let's go to the script editor, and let's create a new script by going to File, New Script. We want to use the empty template, and we will create it in the source folder, main, and create a new one called state machine. The main folder is the heart of your program, the entry point. We use that name because it's inspired by programming languages that use that main function. And we're going to call the script statemachine.gd. Okay. The first thing we're going to do is give that class a name using the class underscore name keyword. Let's call it state machine. And we're going to add an icon after that. So add a comma after the class name, and then you want to go to the Assets 2D Icons folder and click and drag one of the SVG files to add its path to the script here. So you drag and drop it on the script file. When you do that, Godot will use that file as the icon for our state machine in our case. So we can go to the scene now and add a new node. Search for state machine, press enter. If you don't see the icon in the scene tree, you'll have to restart the editor, which I'll do in a moment. But first, we're going to do the same thing for the state script. File, new script, and let's call this one state, right next to the state machine. Save this one, and we're going to give it a class name of state and the state icon. From there, you can select your state machine and add a state node. If you search for state, you will find it instantly. Double click. Okay. Now I'll restart the editor. As I was saying, you need that in case the icons are not working, and you can see that now they are displaying properly in the scene tree. Okay, let's go back to the script editor, and we're going to work on the state.gd script first. So I'm going to close the other tabs and work on that. The state is going to be an abstract type, a base class that we're going to use that guarantees that all the state have the same functions that the state machine can call. So we're going to have functions to handle the input, process, and physics process callbacks. So you can use autocompletion to create them using Godot's base functions. We're going to use the same names. So unhandled input, we're going to return from that. Then we're going to add process. I'll add the return keyword at the end. And finally, we're going to have physics process. And we don't want to keep the callback that Godot expects and is going to use on every state. Instead, we're going to remove the underscore so that the state machine will manually call these functions on one state only at a time. One of the points of a state machine is that it will delegate logic to a single state at any given time. So to remove the leading underscore, select the space underscore in front of your functions. Press Ctrl R to search and replace. So you will have the search field filled based on your selection, and we'll replace that with just a space. Replace all to remove the leading underscore in every function name. These are some base callbacks that we will override in the states that we'll create moving forward. Then we want to add two functions to enter and exit the state. We'll use them to set up the state and clean it up. So to initialize variables and to reset them respectively. So let's create a new enter function. And this one is going to take one parameter. We're going to take a message, and that message is going to be an empty dictionary. We're going to use that for states to communicate with one another. You will be able to transfer a dictionary with any kinds of values between states. Imagine that you have a jump in your game and you can have a normal or a power jump. One way to code it is that in the run state or whatever, if you hold the spacebar down, it's going to enter the jump state with a message saying power jump, for example. So if you have power jump in the message dictionary, you will do a power jump. We'll see how we'll use that in the next chapters. But for now, we're going to add our exit function. And so in the enter function, we will initialize variables, we will connect to signals, those kinds of things. In the exit function, we will reset some variables and disconnect signals. Then we want to make our states work in the context of a hierarchical finite state machine. A hierarchical state machine is going to have states that use a tree-like structure, and you have the parents that can delegate work to their children. We've chosen to do things a little differently, where we will have parents, like a move state, for example, for our character, and the children are going to use the code, the values, the functions from that parent class. So it's always the deepest node that's going to be the one that takes control of the current scene, so of the character, for example, and then it will be able to use its parent instead of having the parent delegate work to the child. I'm going to create a new variable called parent with a leading underscore, and it's going to be a state. And at the start, it's going to be null. This parent is going to be the parent of our state. So I'll duplicate my state and create some fake hierarchy if you want to explain what we're going to do. So I'll create a move state and a run state. Now, we want to get from the run state, we want to get that move state node and keep a reference to it. So run is going to get that parent in the ready function. We can say parent equals get parent. The problem is that with the way the ready function works, Godot is going to create the run node first, and then it's going to create the move node in that case. So if we use that function here, so that statement is going to give us an error in the game. We want to wait for the move node to be available before we get a reference to it in the run state script. To do so, we can use the yield keyword. Yield is going to pause the execution of that function until a given node emits a signal. It turns out that every node has a variable called owner that you can use, and it's a reference to, in the case of a saved scene, the topmost node of that scene. In our case, it's the game node. So you can say yield, so pause the function until the owner node is ready. So when the game node is ready and has been added to the tree, it's going to emit the ready signal in our case. And then all of the functions that yielded at that point will move to the next statement. So to clarify things, this block means that on the ready function, pause, wait for the owner game in that case to be ready, and then resume and get the parent. When game is ready, all of the tree is going to be ready, so we can safely get the parent here.